Let's consider the example of this reaction where we have two nitrogen dioxides reacting to give one dimer, the dinitrogen tetroxide dimer. Here's the equilibrium constant. It is 2.8 at 400 Kelvin. So if we start with 0.1 molar NO2, let's find the equilibrium concentrations of both NO2 and N2O4 product. So knowing just the starting amount and the equilibrium constant, we can determine all the equilibrium concentrations. How can we do that? Let's first write down our equilibrium constant. So we have our equilibrium constant is going to be the product concentration raised to the first power divided by the reactant concentration raised to the second power, and this numerically is equal to 2.8. So we have two variables, N2O4 product and NO2 reactant, but we can reduce this to a single variable by defining an extent of reaction. So we'll let X, the amount of something that reacts in this chemical reaction. So let's let X be the amount of N2O4 that is formed in the reaction. And so we'll let X be the amount of N2O4 that is formed in the reaction. So that's our extent of reaction. So at equilibrium, then the concentration of N2O4 is equal to the initial amount plus how much was formed, which is X. So it'll be the initial amount plus X. The initial amount is 0. Starting, we only had NO2 reactant. So the initial amount was 0, and the amount we formed is X. So the amount at equilibrium is the amount we start with plus the amount that's formed. So 0 plus X. So now we can define the NO2 reactant the same way. At equilibrium, it's the amount we start with, so 0.1 molar. And NO2 is a reactant, so it's disappearing. So we're going to have negative amount. So if we look at the balanced equation, for every one product, we have to react two reactants. So if X is the amount of product formed, double that minus 2X for the NO2 concentration, or the NO2 extent of reaction. So that means that at equilibrium, the NO2 concentration will be the amount we start with minus the amount that has reacted, which is 2X. So this way, we can plug these values into the equilibrium equation, and we only have one variable, X, to solve for. So we'll do that. So the equilibrium constant is equal to N2O4 concentration, that's just X, divided by the NO2 concentration squared, so that's 0.1 minus 2X quantity squared. And Kc is a number, 2.8, so we could just solve algebraically for X to find the equilibrium concentrations. Once we find X, we can just plug X back into here, and that will give us our equilibrium concentration. So let's go ahead and do that. Make some room so we can do our algebra. So we have Kc is equal to X over 0.1 minus 2X quantity squared. I'll expand out the denominator. Okay, so now I'll bring this denominator over to the left side of the equation. And then I'll move x over to the left side of the equation and combine all my terms, and I'll get so I'll get that for my polynomial. So this is of the form which you've seen. So if I have a polynomial in this form, I can use the quadratic expression to solve for x. And in my case, four times kc is a, and then minus this is b, and that is c. So I can just plug those into the quadratic expression and solve for x. Doing so will give me two values for x, and I'll show you how to handle that. So solving for x in my calculator, I get x is equal to 0.175, or the other value is 0.0143. So now we have to decide which value of x we want to keep. So if we go back to our equilibrium concentrations, so I'll write those up here. So at equilibrium, concentration of N2O4 is equal to 0 plus x, and the concentration of NO2 is equal to 0.1 minus 2x. So we'll try both x's and see which one fits. So if we put 0.175 in for x, we get 0.175 for the N2O4 concentration. But if we put 0.175 in here, we'll get a negative value for the NO2 concentration. We can't have a negative concentration. So that means that this root is not applicable to our model. Therefore, we'll use the other root. So the N2O4 concentration is equal to 0 plus x, or 0.0143 molar. And then the NO2 concentration is 0.1 minus 2 times 0.0143. And so that's equal to 0.071 molar. So these are our two concentrations. This one for N2O4 and this one for NO2. So that's how we can use just the equilibrium constant and the starting amount of each substance in the reaction to find the equilibrium concentrations.